Good morning, everybody. Today we are changing an environment and move to topic 6-1, measuring segments and angles. And as always, before we start a lesson, we're going to look at some reviews on the concepts that we need to know before we go into the lesson. So in this review, there are three things that you need to know. The first one is absolute value. The second one is multi-step equation. And then the third one is equations with variables on both sides. So let's take a look at that. Well, for the topic of absolute value, in part A, it says the absolute value of -2 plus 5. And remember, we're going to use order of operations to simplify these expressions. So inside the absolute value, you're going to add these two numbers. So you're going to add -2 plus 5, which will get you +3. But don't forget there is an absolute value around the 3. So you're going to find, what is the absolute value of +3? That means, what is the distance of the number 3 from 0 on the number line. So in other words, or if I were to draw this, right? So if I were to draw a number line, 0, 1, 2, and 3. Absolute value of 3 just means that, well, if you have a dot at 3, how far is this dot away from the number 0 on the number line? So you count 1, 2, 3. So therefore, the answer of absolute value of 3 is just 3. This means that this number 3 is 3 units away from the number 0 on the number line. Now, this is just for explanation purpose, but for shortcuts, the absolute value of any positive number is positive, and the absolute value of any negative number is still positive. Okay, so pretty much anything that you get out of an absolute value, it's going to be 0 or a positive number. Well, moving on to part B, this one is absolute value of -3 minus -2. So same thing, we're going to use order of operations to simplify the inside. So we're going to leave the absolute value sign like this. Well, -3 minus -2, that's the same as -3 plus 2, because two negatives becomes a positive. Then from there, you're going to find what's -3 plus 2. So again, I'm going to keep the absolute value sign. -3 plus 2 is just -1. And the absolute value of -1, it just becomes +1. And then that's the review on the absolute value. For multi-step equations, you have this equation 4x plus 10 plus 6x minus 3 is equal to 77. So when you have multi-step equation, the first thing you have to do is combining like terms. So you have 4x and 6x here. So when you combine them, 4x plus 6x is 10x. And then the next thing you have +10 minus 3, and then so 10 minus 3 will get you +7, and you bring the equal sign down and then the 77 down. So 10x plus 7 is equal to 77. Then from here you just have to add or subtract any constant that is next to the linear term, which is 10x. So since this is +7, you do the opposite of operations, which is -7 on both sides like this. And then these positive and -7 will cancel. You're left with 10x is equal to 70. And then at the end, 10 times what number is 70? So to find that out, you're going to divide both sides by 10. And then you get x is equal to 70 divided by 10 is just 7. So the value of x is 7. And we previously learned how to check this answer. All you have to do is just plug it back up, the answer that you found, which is 7, into the equation to see if this side is equal to 77. So if the left equals to the right, that means your answer is correct. Likewise, for equation with variables on both sides, for this one you have 2x minus 3 is equal to 5x plus 9. Well, let's take a look at how do we solve this. So to do that, since you have a linear term on both sides of the equation, 2x and 5x, we're going to subtract the smaller coefficient, which is 2x on both sides like this. Okay, and then from there you cross out the 2x, and then you're left with -3 on the left, and then 5x minus 2x is 3x plus 9. Then from here, again, just like the middle part, you're going to, since you have a +9 here, you're going to subtract 9 on both sides like this. So the +9, -9 cancel. And you're left with -12 is equal to 3x. And then at the end, 3 times what number is -12? So you divide both sides by 3 to find out what is that number. So -12 divided by 3 is -4. So -4 equals x. So that means the answer is -4. Same thing, I want you to plug in -4 into both sides of the equation. Simplify both sides to see if the left equals to the right. And if so, then you're getting the same answer. Well, once you have reviewed and mastered these three concepts, we're ready to move on to 6-1. Now we're on 6-1, measuring segments and angles. And before we're doing any calculations, let's take a look at something called undefined terms. Undefined terms are words or terms whose meanings are accepted without formal definitions. The terms points, lines, and planes are undefined terms that are the basic building blocks of geometry. So if I were to ask you, hey, what is a point? There's not really anything that you could tell me more than just a point. It's just a point. It's a dot. That's it. There's not really any detail rather than just a dot. And in terms of diagram, we'll put a dot, and every dot has a name, and we use a capital letter to indicate the name of a point. Never use lowercase, but uppercase only. And for notation in words, when we write in sentences, in writing, we're just going to say point P. So this P is also a capital letter. Now, of course, we're not going to name every single dot P. We could name them A, B, C, D, all the way to X, Y, Z. We just have to use capital letters when we name points. And a point is a location and has no size. It's just a dot without any size. The next thing that we're going to learn, the next undefined term that we're going to learn is something called a line. We kind of intuitively know what a line is. A line is an infinite number of points on a strict path that extends in two opposite directions with no end and has no thickness. So this is a diagram or a picture of how a line looks like, and a line should have 2 points. Either 2 points, or it doesn't have a point but with a cursive letter to name a line. So if there are 2 points or more than 2 points on the line, all you need to do is just to put the 2 letters on the line, which is AB or BA, with like a little line symbol on top of it, and that will be the notation when you will write it in a sentence. Or if you don't want to write it this way, let's say if there's no point on the line and if there's just only a line, we're just going to name it with a cursive letter, line L. And again, we don't have to name each line just with a cursive L. You could name it cursive A, cursive B, cursive C, cursive D. It's just lowercase cursive, okay? Now, if you have 2 points on the line, then you could use those 2 points. You could write the 2 capital letters of those 2 points on the line and to name the line itself. So if this is C and D, you're going to write CD with capital letters and with a little line symbol on the top. So that's how you name a line. We always use 2 letters that are the points on the line, or if there's no points on the line, then it's just going to be 1 cursive letter. The last undefined term that we're going to talk about is called a plane, which is an infinite number of points and lines on a flat surface that extends without end and has no thickness. Think of this tabletop or even this piece of paper as a plane, and it's just that the paper will extend infinitely if it becomes a plane. So kind of like a wall or a floor or just the ground, right? So those are all considered a plane. It's just that they all extend infinitely. Well, this is a diagram, so you're just gonna draw like a little kind of like a parallelogram kind of shape to indicate it's a plane. It's like a piece of paper. And if there are points on the plane, right, think of like a piece of erasers. If there's 3 erasers on the tabletop, then you could use those to name the plane. So same thing, to name a plane, you need 3 dots on a plane, if they exist, to name the plane. You could name it plane XYZ or plane ZYX or plane YZX, any order of letters that you could scramble them, and they all indicate the same thing. So it doesn't have to be XYZ all the time. It could be just ZYX, XZY, YXZ, however order you want to put it in. Now, of course, sometimes not all the planes will have points on it. Sometimes you just don't have any points, just like this. If I were to cover them, then this plane has no points, so we're just going to use a capital letter, just 1 capital letter, to name the plane. So we could say that this plane, we're just going to name it M, so it's plane M. Now, keep in mind that this M is not a point. I don't see there's a dot next to it, so this M is not the name of a point, but it's the name of a plane. But if there are 3 points on the plane, then you could use 3 points to name the plane. Now, you cannot use 2 points and you cannot use 1 point. To name a plane, you need to use all 3 points. Now, of course, if there's an extra point, let's say I'm just going to create one here. Let's say there's an extra point, and let's say you have a point A. Then you have a lot of ways to name this plane. You could name it XYA, AYZ, YAX, YAZ, XAZ, XZA, or XYZ. There's a lot of ways for you to name the plane, but you always need 3 points to name the plane. 3 points that are not on a strict line, and none of these form a strict line, okay? And we'll talk about what are the names for points that are on the strict line or on the same plane, which is going to be the next 2 words. So the next 2 words they're going to learn, the first word is called collinear points. They're pretty much the points on the same line. So let's take a look at these 2 points, A and B. Well, we're going to say point A and point B are collinear, or they're collinear points because they're both on the same line. Now, if I were to create another point, let's say if I were to put a point here, right, and let's say C, right, let's say if I put C here, then you can say, well, point A, C, B are collinear because all of them lies on the same line. And of course, to name this line, you don't have to have AB. You could write AC with a line symbol on the top, or you could write CA with a line symbol on the top, or you could write BC with a line symbol on the top, or CB with a line symbol on the top, right? There's a lot of ways for you to name a line, and you just need 2 points to name the line, okay? And for coplanar points, there are points on the same plane, okay? So in other words, we're going to say point X, point Y, point Z, and point A are on the same plane, and therefore they're called coplanar points, okay? So likewise, we talked about this earlier. We don't have to name it by X, Y, Z, but we could say that's X, Y, A. We're going to say this is plane Y, A, X. There's a lot of ways to name a plane, but you always need 3 points to name a plane. So let's take a look at example 1 to kind of practice on how to write things in notations. In example 1, number 1, with this diagram, it asks you to name 5 points. Now, there's a lot of points in this diagram. I see there's H, D, G, F, I, J, K. And all you have to name are just 5 points, just any of the 5 points. So I'm just going to pick 5 letters and separate them with comma. So you're going to say H, G, I, J, and K. That's it. Now, of course, these are not the only 5 answers. Someone else might have picked D, H, G, J, F, and that's totally fine. For number 2, it says name 3 collinear points, and there's more than one answer for this one. So I just need to find 3 points that lie on the same line. So I see that these 3 dots are on the same line. So we're going to say D, G, F. So we're going to say D, G, F. Now, of course, this is not the only answer. Another set of answers would be these 3 points because it lies on a different line. We're going to say, well, there's another answer, which are I, G, and J. So I, G, and J is another set of 3 collinear points. The number 3 is says name 4 coplanar points. So coplanar means points on the same plane. So this is a plane, and we want to find out, well, which points on the plane. Now, so let's take a look at I. I is above. It's above on top of the plane, so I doesn't count. J is below. It's at the bottom, underneath the plane, underneath the table, so that doesn't count. And K just hanging in the air is not, it's just by itself. That is kind of like, I think it's underneath the plane, so that doesn't count as well. So the only 4 points that are on the plane would be H, D, G, and F, and you could put them in any order. H, D, F, and G. Okay? The number 4, it says name the line that is not lying on the plane in 3 different ways. Well, first of all, we have to identify which of these 2 lines they're not lying on the plane, okay? Which is this one. This one is cut through the plane, and this line has 3 dots, and we could use these 3 dots to name this line, okay? But remember, to name a line, we just need 2 dots. Out of these 3 dots, we just need 2 letters to name a line. So we're going to say IG first. So we're going to say line IG with a little line symbol on top. Or we can use IJ, so IJ with a line symbol on the top. Or we could use GJ, right? So GJ with a line symbol on the top. Now it says letter in letters in different order do not count as a different way. So if you put GI and IG, that does not count as an answer. You notice that I use different letters, IG, IJ, and GJ in each of the answer, okay? So this is what the parentheses mean. Letters in different order do not count as a different way. Well, likewise, in number 5, it says name the line on the plane in 3 different ways. Well, there's only one line left, which is this line right here. It's kind of like lying on the plane. It's on the plane, right? So there are 3 dots on this line, and you only need 2 dots to name this line right here. So same thing, you could have DG, DF, or GF. So we're going to write DG with a line symbol on the top, DF with a line symbol on the top, or GF with a line symbol on the top. Okay? The number 6, it says name the plane in 3 different ways. And again, letters in different orders do not count as a different way. So I see there are 4 dots, there are 4 points on the plane. And remember, we cannot use 3 of those that is on the same line. So you have to use H at some point. So you could use HDG. So we're going to say plane HDG. That's one way to name it. Now, of course, plane DHG or GHD, that does not count. We have to use another set of letters to name the same plane. So another way would be HDF. That will work too. HDF. So we're going to say plane HDF, right? That's another way. Or you could say besides HDF, we could use HGF, right? That's another way. So plane HGF. Every time you see like an invisible triangle, right? You see HGF forms like a triangle, HDG forms a triangle, and HDF forms a triangle. Every time you see that you could form like an invisible triangle between the 3 letters, you could use those 3 points to name the plane. Now, of course, DGF doesn't work because if you look at DGF, it doesn't form a triangle. It just forms a line. So therefore, you cannot use DGF to name the plane. Well, now that you learn what are undefined terms, the next set of terms are actually defined. Well, what are defined terms? So in geometry, new terms are defined using previous defined or known terms. So let's take a look at the next 4 terms. The first one's called a segment. So a segment is the part of a line that consists of 2 points called the endpoints and all the points between them. So this is no different than a line except that lines does not end, but segment ends. So this is a segment which has an ending, kind of like this pen right here. It has an end. And we're going to use 2 letters, 2 points to indicate a segment. And for notation, we use 2 letters, A, B, or BA, with a segment symbol on top of the 2 letters. Now remember, you have to put some symbols on top of the 2 letters because otherwise, if you don't put it, we won't know whether you're talking about line or segments. So you need to have a segment symbol on top of the 2 letters. So it could be segment AB or segment BA like this. Okay? The next term is called a ray. A ray is the part of a line that consists of 1 endpoint and all the points of a line on one side of the endpoint. Think of it like a sun ray, like a sunlight. It only shoots in one direction. So for this particular ray, it starts at M and it shoots into the direction of the point N. Okay? So therefore, for notation, now this one, the order matters. So you have to start with M because this is where you start. And then you're shooting into the N direction. So the arrow is always pointing to the right. Now, you never write like this. I know that some people are like, well, what about if I write NM with an arrow shoot like, to the other side? That's a no, right? We cannot do this, right? It's always, for notation, we always draw the ray symbol pointing to the right with the starting point on the left and then the end, and then the direction on the right of the letter notations. Okay, so of course another person might argue that, well, can I just write NM like this? I'm like, no, this is a different ray. This means just that you start at N and then go into the M direction, which is not correct as well. So there's only one way to write notation for rays. Well, the next term is called the opposite rays. And opposite rays are rays with the same endpoint that going into opposite directions. So there are two rays here. They both start at T, and one shoot to the left, which is ray TS, which is right here. And then the other one shoot to the right, which starts at T and then go to the right direction, and which is the ray TU. And the reason that it's opposite is because they're going to opposite direction. One to the left, one to the right, and they start at the same starting point. Now, of course, it doesn't have to be left and right. It could be up and down as well. Okay, so of course, I could just draw something like, like this is T, and TS will be, let's say if TS shooting up, then TU will be shooting down, right? Now, this is not a notation. That's just another way to draw the diagram, okay? Well, the last defined terms they're going to learn, it's an angle. What is an angle? You kind of know ahead of time what is an angle. But in formal definition, an angle is formed by two rays, okay? Two rays, one is QR and the other one is QP, with the same endpoint. Each ray is a side of the angle, and the common endpoint is the vertex of the angle. So this is called the vertex. The vertex is Q, okay? And there are ways to name this angle. So you could name this angle Q if there's only one angle standing here, right? There's no other angle next to it. We could name angle Q. We could also name it with three letters. Name angle PQR or RQP. But however, the vertex has to be in the middle of the three letters. So Q has to be in the middle. It cannot be on the left, it cannot be on the right. It has to be in the middle. Now, another way to name it could be RQP, and that works too. But you also notice that the Q has to be in the middle of the three letters. Cannot be on the left or on the right. Okay? Now, if an angle has a number in it, right, has a number inside, we could also call it angle 2, which you probably have seen this before, angle 2, okay? So these three are acceptable, except sometimes you may not name an angle with only one letter. And I'll give you an counter example. Let's say you have two angles, they're next to each other. Let's say you have something like this, okay? Let's say this is A, this is B, this is C, and this is D. Now, if I were to ask you, hey, name this angle for me, well, you have to say this is BAC or CAB. You cannot name angle A, because if you name angle A, I won't know which angle you're talking about. Are you talking about this angle? Or are you talking about this angle? Or are you talking about the entire angle, right? So you cannot use one letter to name this angle. So this angle right here, it's going to be angle BAC or angle CAB, right? This angle that I kind of shaded here. You cannot name angle A, because otherwise it's too vague. I don't know which angle you're talking about. So just be aware. Well, let's continue more problems with example 1 with the same diagram. So question number 7, it says name 3 different segments. They're not lying on the plane. So remember, not lying on the plane is this line right here. But remember, this line has 3 different segments. You have the short one, another short one, and a very long one, okay? So we're going to take a look at the short one here first, okay? So this one is going to be segment IG with a segment symbol on the top. Another one would be GJ, okay, GJ with a segment symbol on the top. And then another longer segment, it's segment IJ with a segment symbol on the top. And then for number 8, it says name 3 different segments. They're lying on the plane, which is going to be this line right here, and this line, it's going to consist of 3 little segments. The short one on the left, the short one on the right, and then the longer one that's across from D to F. So we're going to say DG for the left segment with segment symbol on the top, and then GF on the right, GF with a symbol segment on the top, and then DF with a symbol segment on the top, like this, okay? Number 9, it says name a pair of opposite rays lying on the plane. Well, on the plane would be this right here. So you start at G, and then you shoot to the left, and you shoot to the right. So it's going to be GD for the ray that shoot to the left. So you're going to write G first, and then D, and then point the ray towards the right direction. And then for this one, it's going to be GF. You start at G, and then shoot towards the F direction. So it's GF. And then that's it. Then the last one, number 10, it says name a pair of opposite rays not lying on the plane. So it's going to be this line right here. So you start at G, and you shoot up, and you shoot down. So it's going to be GI with a ray symbol on the top, and then GJ with a ray symbol on the top. And then that's it. Let's get into some mathematics and calculations now. There's something called Ruler Postulate, which you don't really need to use it for calculating stuff, but you just need to know because that's how we set up calculations. So Ruler Postulate just says that every point on the line can be paired with a unique real number, and this number is called the coordinate of a point. So if you have a point x and point y, we could always use a ruler to find out the coordinates of these 2 points. So with a ruler, we see that x is located at the number 3, so we're going to say the coordinates of x is 3. Likewise, I see that the point y is at the number 7 on the ruler, so we're going to say the coordinates of y is 7. Now, segment addition postulate, it says that if point A, B, and C are on the same line with B between A and C, then the length of AB plus the length of BC is equal to the length of AC. So in other words, if we were to add the length of this little segment and the length of this little segment, don't you agree it's just the same as the length of the entire segment? Like this piece plus this piece is equal to the entire piece. It's intuitively true. I think we all agree to it. We just have to state that so that way you know that, well, if you know this length and you know this length, you could add them to find the total length from the start to finish. Let's take a look at example 2a. In example 2a, you have a diagram here, and I see that there are 4 points with coordinates for each one. So for part A, it says find length CD. So I see that C is at coordinate 1 and D is at coordinate 4. Now, since you have a diagram with some tick marks, you could count the length. You could just say, well, that's 1, 2, and 3. So that the length would be 3 units long. Now, to show work, you're going to just subtract these 2 numbers. So you're going to put absolute value of 4 minus 1, which is pretty much the absolute value of 3, or it's going to be positive 3. So you could do 4 minus 1, or you could just do 1 minus 4. Okay? It doesn't matter what number subtract what number, as long as you put absolute value in it. Now, 1 minus 4, it's going to get you an absolute value of negative 3, which at the end, it still becomes positive 3. Because remember, absolute value means the distance between the 2 points. So the distance between C and D is just positive 3. Okay? Likewise, let's find length AC now. I see that A is here, C is here. So without counting, we're going to subtract these 2 numbers. So you're going to put negative 3 minus 1, which is absolute value of negative 4, which is positive 4. Or you could subtract the other way. You could do 1 minus negative 3. Now, there are 2 negatives here, okay? So be careful on that. 1 minus negative 3. So 1 minus negative 3 just same as 1 plus 3, which is 4, right? So the absolute value of 4 is just positive 4, okay? So this is the example 2a where you could count in the picture to find a distance or use a shortcut involving absolute value. Now in example 2b, now this time you have a diagram and you cannot count anymore because these numbers are a little bit too large to count little by little or one by one. So in part A it says find length jk. I see that the coordinate for j is 5 and the coordinate for k is 12. So you have no other choices but you have to use the absolute value method. So you're going to do absolute value of 12 minus 5, which is absolute value of 7, which is positive 7. Now, you could also do 5 minus 12 if you want. You're just going to get a negative number inside the absolute value. But once you take the absolute value of that number, it's still going to get you positive. So there's 2 ways to do it. Likewise, in part B, if I ask you to find length km, well, the coordinate for k is 12 and the m is 27. So you could do absolute value of 12 minus 27. Or 27 minus 12 doesn't matter. And so you could do 12 minus 27, which is going to be negative 15, okay? Now the absolute value of negative 15 is going to be positive 15. So that means the distance between point K and point M is 15 units apart. So similar to ruler postulate, that you could put any points on a coordinate on a ruler, you could also put any angles on a protractors. So this one, it says every angle can be paired with a unique real number on a protractor, and this number is called the degree of an angle. So we could always measure how wide or how narrow is an angle by a protractor with its degree. Okay? And just like the segment addition postulate, angle addition postulate, it just says if you have 2 little angles, when you add them up, it just becomes the measure, the degree measure of the largest angle. So if you have measure of ABD, which is this angle at the bottom, and plus the measure of angle DBC, which is the angle on the top, then that will equal to the measure of the entire angle ABC, which is this whole thing right here. Now this little m here, it just means measure, right? It indicates the word measure. Okay, indicates the word measure. It does not indicate anything else but measure. So we're going to say measure of angle, that's an angle sine, ABD, plus the measure of angle DBC is equal to the measure of angle ABC. Well, with the protractor postulate and angle addition postulate, let's take a look at example 3a and 3b. In example 3a, it says that if measure of angle SPR is 62 degrees, let's actually label that. SPR is 62 degrees. And the whole thing, SPQ, is 119 degrees, which we could kind of just draw like this, right? And just name it 119 degrees. Well, how can you find the measure of QPR, which is this one right here? Well, very easy. All you have to do is, well, you have to find out, well, 62 degrees plus how many degrees is equal to 119 degrees. So all you have to do is subtract them. You could do 119 minus 62. And then when you use a calculator to find out what is the answer is going to be 57. Now don't forget to put the degree symbol on the top. So it's going to be 57 degrees like this. Very, very easy. Okay. Now the next one is not so easy because this is actually on question number 8 on Pearson. It says that if measure of angle of ABD is 77 degrees, which is this whole thing, ABD is 77 degrees. Well, what is the degree measure of the two little angles, ABC and DBC? Okay, ABC is the bottom one, DBC is the top one. So you have to use the angle addition postulates to set up an equation because I have some variables here, 3x plus 3 and 6x minus 7. Now, don't you agree that if I were to add these two expressions, the whole thing is 77? All you have to do is just set it up like that. So you have 3x plus 3, that's the measure of the top angle, plus the measure of the bottom angle, 6x minus 7, is equal to the whole thing, which is 77. Okay, and then from there, all you have to do is just like on the review section, you just have to combine like terms, and you just have to find x, okay? But there's more stuff to it. We'll talk about it later. So let's combine like terms first. So you have 3x and 6x, which is 9x. 3 minus 7, which is negative 4, is equal to 77. And you're going to add 4 on both sides. So I'm going to put plus 4 and plus 4. Okay. And then you get 9x is equal to 81. Well, divide both sides by 9. You get x is equal to 9. Now, this is not your final answer, though, because that does not mean the angle is 9 degrees. You have to find the measure of angle ABC, which is the expression 6x minus 7. So you have to plug it in. So 6x minus 7, right? The measure of angle ABC is 6x minus 7. Replace the x with 9, okay? And then use order of operations to simplify. So 6 times 9 is 54. 54 minus 7, it's going to be 47 degrees. So the bottom angle is 47 degrees. Well, what about the top angle? Well, measure of DBC, okay? Well, measure of DBC, it's going to be 3x plus 3. So replace the x with 9. Okay. Well, 3 times 9 is 27. 27 plus 3 is 30 degrees. Okay. Now, how do you check your answer is correct? Well, let's take a look at, well, at 47 and 30. Isn't 47 plus 30 equals 77? Well, it's a very easy check because if you have these two angles add up to the largest angle, then that means you did your math right, and then that's it. That's the end of the problem. Well, the next concept you have to learn is something called congruent segments and congruent angles. These are just notations. There's not really a lot of math here. It's just that if you have two segments that are exactly the same length, we're going to use these little tick marks to indicate that they are the same length. So here we're going to say segment AB is congruent to segment CD. Now, be careful, you don't use equal sign here, you use congruent, because here we're talking about the segment itself. Now, when do we use equal sign? Well, we use equal sign when you don't use the segment symbol. You're going to say AB, right, the length of AB is equal to the length of CD, right? So if you use equal sign, you should not have the segment symbol on the top. But if you use the congruent sign, then you should have the segment symbol on the top. Well, likewise, if there's another pair of segments that are congruent, that means having the same length, then you're going to use another set of tick marks. In this case, we're going to use 2 tick marks, or you could use 3 or 4 if you want, but we're just going to use 2 because we already used 1 here. So here we're going to say segment PQ is congruent to segment RS because PQ, the length of PQ is equal to the length of RS, right? So there's a difference between these notations, okay? Well, likewise for angles, angles that the same measures are congruent angles. And if these two angles having the same measure, we use 1 arc inside the angle to indicate that these two angle measures are the same. We're going to say angle TUV is congruent to angle XYZ. Now, we cannot use equal sign here because we're talking about the angle itself, right? But if you want to talk about the measure, we're going to say measure of angle TUV is equal to the measure of angle XYZ, right? That would be the correct way to use an equal sign. Well, likewise, if you have another pair of angles that are congruent or have the same measures, this time you're going to use 2 arcs. You can use 3, you can use 4, you don't have to use 2. But just for simplicity purpose, we're going to use 2 arcs here. And here we have angle FGH is congruent to angle JKL. And the reason that is true is because the measure of angle FGH is equal to the measure of angle JKL. So that's the difference when you use when to use an equal sign and when to use a congruent sign. Well, in example 4a, let's practice how to read congruent symbols for segments and angles. Well, here it says if measure of angle XWZ is equal to 127 degrees, which let's take a look by drawing this whole thing. XWZ, by this whole thing, is 127 degrees. What is the measure of YWV? So YWV is right here. Well, first of all, it says this angle is 32 degrees right here, and I see that there's 2 arcs. So if this is 32, this is also 32 degrees, and then you just have to find out what is this. Now remember, don't you agree that if I were to add these 3 little angles, isn't that just same as the measure of the largest angles? So all you have to do is just have 127, subtract these 2, and you get the remaining parts of the angle. So you're going to do 127 subtract 32, subtract another 32, and that will equal to your final answer. So I'm going to use a calculator, and I get 63 degrees. That means the measure of YWV is 63 degrees. Well, likewise, in example 4b, it says find the length of HF. HF is this part right here. Well, I see that there's some tick marks here. So I see that the ones that has 2 tick marks is 11 centimeters long. That means this part is also 11 centimeters long. Then the part with 1 tick mark is 8 centimeters long. That means this is also 8 centimeters long. And if I were to find the entire length, HF, don't you agree that we're just going to add these 2 numbers, 11 and 8? So you're going to put 11 plus 8, which is 19 centimeters. Isn't that easy? Well, finally, in example 4c, we're going to take a look at a more complicated problem. So here it says if measure of NOP is 31 degrees, let's actually mark it. NOP is 31 degrees. And measure of NOQ, which is the entire thing, NOQ, is 114 degrees. What is the measure of ROQ, which is this one right here? Let's call it X. Now, if I call this X, don't you agree that we also can call this X because they're the same angle measure because of these 2 arcs? So we're going to use the angle addition postulates to add these 3 angles to set it equal to 114. So to set up the equation, it's going to be 31 plus x is equal to 114. Let's combine like terms. X plus x is 2x, so 31 plus 2x is equal to 114. Well, you're going to subtract 31 on both sides like this, okay? And you're going to have 2x is equal to 114 subtract 31 is 83. And if I divide both sides by 2 like this, then each angle, will you have a decimal, but a very nice decimal. So 83 divided by 2 is 41.5 degrees. So that means the measure of ROQ, which is your x, is going to be 41.5 degrees. Now, before we end the lesson today, there are a couple problems on Pearson's homework that I would like to go over and start with you, so that way you know what's the first couple steps before you get to the final answer. For example, on question number 7 on Pearson's, you see this diagram. Now, these numbers might be different depending which version you have, but let's say you know the length of RS, which is 7y plus 3. And you know the length of ST, which is 2y plus 3. And you know that the entire length, RT, is 51. Well, you have to find the value of y, the RS, and ST. So all you have to do is just set up an equation, add these two, and set it equal to 51. So you have 7y plus 3 plus 2y plus 3 is equal to 51. And then at some point, you find me what y equals to by solving this equation. Now, once you find y, don't forget to plug it back into these two expressions to find the length of each one, RS and ST. And that will be the process to do number 7 on Pearson. The next one is question number 10. Question number 10, this one is a complicated looking diagram, but we could still extract it little by little. It says that if the measure of QOS is 49 degrees, which is right here, let's actually label it. QOS is 49 degrees, and the measure of POR is 58 degrees, so POR is right here. This is 58. Okay, and then the measure of POQ is 21 degrees. Now, POQ is right here, which is 21 degrees. They want you to find what is the measure of ROS, okay, ROS, which is right here. Okay, they want you to find what is this one. Well, you know the entire thing already. Don't you just add 21 and 49 to get the entire thing, right? 21 plus 49. So 21 plus 49 would be the entire thing, which is 70 degrees. Okay, so you know that the whole thing is 70. Now, if you know that this part is 58, how do you find this part? If you know the entire angle, POS, it's going to be 70 degrees. So you just have to subtract them. So you have 70 minus 58, and you get the remaining part. So I'm going to let you finish that problem on Pearson. Well, question number 15, it says that if PT is 3x plus 3, which is right here, right? This whole thing right here is 3x plus 3. And TQ, which is right here, is 5x minus 9. Well, what is the length of PT, right, which is right here? Now, remember, you have two tick marks here, right? One tick mark here, one tick mark here. That means that these two are equal. So all you have to do is just set them equal to each other and then find x and then plug it back in. So you're going to set up 5x minus 9, set it equal to 3x plus 3. And then at the end, you should get what x equals to. But this is not your final answer. After you found x, you plug it back in here to find what is the length of PT, and that will be your final answer. Well, lastly, on question number 16, this one does not have a diagram. We have to create that on our own. So let's actually do that. So it says point C is in the interior of ABD. So let's actually draw a random angle. Okay, so let's say this is A, this is B, and this is D, okay, and it says point C is in the interior. That means it's right in the middle. Okay, so let's say C is here. Okay, this is point C, and it says that ABC, okay, ABC is same as CBD. So that means these two must have the arc. Now it says if measure of ABC is 5/2 x plus 18, okay. And the measure of CBD is 4x. What is the measure of ABD? Okay, so first you have to find out, well, what is the measure of these two angles? Well, remember, they're equal to each other. These two angles are the same, so that means you set these two expressions equal to each other. So you're going to have 5/2 x plus 18 is equal to 4x. Now, you have an equation that involves a fraction. Remember, we don't want to work with fractions, we want to get rid of the fraction. So you're going to multiply both sides by the least common multiple, which is 2 and 2. And you're going to use distributive property to get rid of all the fractions. Well, 2 times 5/2 is just 5x. And then 2 times 18 is 36. And then 2 times 4x is 8x. Okay? And then from here, you subtract 5x on both sides. Okay, and then you get 36 is equal to 3x. And then once you divide both sides by 3, then you get x is equal to 12. Now, again, this is not your final answer. You have to plug it back in. So if you know x is 12, you plug it back in and find out what is the measure of this. you plug it back in to find out what's the measure of this, and then at the end, to find out what's A, B, D, you add these two together, okay? And then that'll be your final answer. Well, that's it for this lesson, which is a little bit long, but for the next couple minutes, we'll remind you how do you log on to your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks. So if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So, well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that is not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, I only got 3% just because I only answered one question correct. The rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.